Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 2.4, Problem 20. This is Section 2.4, Problem 20. It says multiply the fractions. We have 1/7 times 5 2/3 times 4. So we have a regular fraction, a mixed number, and the whole number all multiplied together. So once any part of it becomes a fraction, you have to treat them all as fractions, basically. And fractions written in a form that have only a numerator and a denominator. I can't have a mixed number like the 5 2/3 with a number in front. So the 1/7 is good the way it is. Let me just bring that down and leave it. Times the middle number, the mixed number, has to be written as an improper fraction. It can have only a numerator and a denominator. I can't have the whole number in front. So to do that conversion, I will multiply the denominator times the whole number in front. So I will multiply 3 times 5, which gives me a 15. Then I'll take that result of 15 and add going up. I will add the 15 plus 2 more, which is 17. So it'll be times 17 over 3. Now, the 4 on the end is just a whole number. It doesn't have a numerator or a denominator. That's a little easier to deal with. Any whole number can be turned into a fraction by just putting a 1 under it. So instead of 4, I can just write it as 4 over 1. Now it's a fraction with a numerator and a denominator. Now all three values have only a numerator and a denominator. Now I can multiply numerator times numerator times numerator. That'll give me the numerator. Then denominator times denominator times denominator. And then reduce if I can. Usually if the numbers are big, this is the point where you want to see if you can pre-reduce. You want to look at any number in the top and see if it can reduce with any number in the bottom. But in this case, you can't. The 1 won't reduce. Obviously, 17 is prime. It's not going to reduce. The 4 is even, so you want to look for anything else that's even in the bottom, but you can't find anything. So I'm not going to be able to reduce it. So coming across top times top times top, I'll have 1 times 17 times 4. 1 times 17 is easy. That's 17. Then 17 times 4, I can see that that's 68. You might want to go off to one side and multiply it out. But times 4, I figure I can just double it twice. If I double the 17 once, it's 34. And then to double it again, times 4, it'd be 68. So 1 times 17 is 17. 17 times 4 is 68. So my numerator is 68. Now the bottom is a little easier. 7 times 3 times 1 is 21. 7 times 3 is 21. Then 21 times 21 stays 21. So I have 68 over 21. Now that's an improper fraction because the numerator is larger than the denominator. But if the instructions for the problem don't specifically say that you can't leave it that way, then it's good. You're done. Now, if they do say that you can't leave it that way, what you have to do is put it back to something in this form, a mixed number, where you have a number and a fraction combination. So the way to make that conversion is divide the denominator, in this case 21, into the numerator, which is 68. So 21 won't divide into 6 at all. 21 will divide into 68. Well, I can see 3 times 20 is 60. 3 is really the number to start with. So it'll go in 3 times. 3 times 1 is 3. 3 times 2 is 6. So now I have 68 minus 63. My remainder is 5. So the number in front is the whole number. The remainder is the numerator. And what was the denominator, the number outside of your division, stays the denominator. So if they will allow you to leave your answer as an improper fraction, 68 over 21 is good. Or if they say that you can't do that, with a little bit of work, you can convert it to 3 and 5/21, like that.